Well, in this question, we are now in a position to find what is the resultant electric field at the point P at a distance of 0.33 meter from each charge. Okay, so what is the background of this question? We have two small point charges that are vertically spaced, okay, by a short distance. So the figure is given to us, both positive charges, 4 into 10 raised to minus 13 coulomb. Both point charges are spaced apart, and vertically the distance between them is 0.5. Now, we are in a position to find what is the electric field at this particular point B. So what is the basic idea behind it? If you want to find a electric field at any point due to point charge, at that point we have to keep a one unit positive charge. I mean the unit positive charge. So we have to keep a unit positive charge at that particular point. We know the electric or electrostatic force will definitely act between this 1 coulomb charge and 400 raised to minus 13 coulomb. In which direction this force is actually acting? In which direction? Both are positive in nature. So what happens? This will repel away like this. 1 coulomb will be repelling each. Okay, so this force is actually the electric field. So I'm just marking this point as A, and this is actually the point C. So this is actually the electric field value at the point B due to A. So I'm just marking this as electric field. That value, I'm just marking it as electric field at B due to A. That is EBA. I'm just marking the direction. Hope you got it. Now, similarly, this 1 coulomb charge will definitely experience a force or electric field strength due to this point charge at the point C. So what happens? That will also repel. So I will use a different color to represent the same. So this will be repelling like this. This will be repelling like this. And what is this electric field? This is the electric field. This is the electric field at B due to, okay, this is the electric field at B due to the point charge at C. Okay, then you can use some mathematics here, the basic mathematics. What is that? Vertically opposite angles are same. So if this angle is 49, definitely this angle is also 49. So definitely this is 49, this angle is also 49 degree. Hope you got it. Now you can resolve this electric field. Why? Electric field is a vector quantity. So we can resolve this into two components. How we can resolve this into two components? This electric field at the B, if you are resolving in the x-axis, the component is EBC cos 49 degree, because the component nearer to the angle, that will be always cos component. Then the vertical component will be what? The vertical component will be EBC sine 49 degree. So this is the components of EBC. Similarly, we can resolve the components of EBA. How we will resolve this into EB components? This EBA, if you are resolving in the x-axis, yes, the same angle. So EBA, this value is EBA cos 49, because this angle is actually nearer to the axis. So EBA cos 49. Then if I'm resolving down, what happens? This becomes EBA sine 49 degree. Now we are in a position to find what is the value of EBC and EBA. So what is EBC and EBA? Recalling, what is that? EBC and EBA are the electric field due to respective point charges at the point A and C. And this electric field we are calculating at the point B, correct? So quickly, I would like to review, because if you have a point charge and if you want to find what at any point P, r distance away from point charge, the value of the electric field at the point P is equal to what? 1 by 4 pi epsilon 0 Q over r square. So that is the formula. Okay, so we can use the same formula here. So what will be the value of EBC? The electric field at B due to the point charge C. EBC will be 1 upon 4 pi epsilon 0. What is the charge? 4 into 10 to the power of minus 13 divided by what is the distance between B and C? 0.33, correct? 0.33 square. So 1 by 4 pi epsilon 0 is 9 into 10 raised to 9, correct? So EBC, if I'm substituting this value, I'm writing the exact magnitude, 9 into 10 raised to 9, that is 1 by 4 pi epsilon 0 into what? What is that charge? 4 into 10 to the power of minus 13 divided by 0.33 square. Now ball is in your court. Take your calculator, input these values. Okay, so try to figure it out. What is this answer? 9 multiplied by 10 to the power of 9 into 4 multiplied by 10 to the power of minus 13 divided by 0.33 square. So the value will be 4 out of, I'm getting the value in fractions, that is 4 out of 121. So this is the value of the magnitude of this EBC, 4 out of 121. Then what about EBA? Because now values are changing, correct? The numerical values 9 into 10 raised to 9, charge is same 4 into 10 raised to minus 13, distance is also actually same. See, the distance is also 0.33, 0.33 square. So if you're plugging these values, we will get 4 out of 121, right? So we got individually what is the value of the electric field due to the point charge C as well as A at the point B. Yes, we got that value. Now you can see at this point B, or at this particular point, at that point B, you can see two horizontal electric fields as well as two vertical electric fields. So there will be definitely a tug of war between EBC sine 49 and EBA sine 49. We already calculated what is the magnitude of EBC as well as EBA. Since EBC and EBA magnitude are same and sine 49 also same, so what happens? These two vertical components will cancel out. Am I right? Then only what happens? There will be a cumulative effect. So EBC cos 49 and EBA cos 49 will be added up together. Why? Because both are actually acting in the same direction towards the positive x-axis. Therefore, what will be the net resultant electric field? That is what they're asking, right? So resultant electric field. So according to definition in vectors, if both vectors are actually acting in same direction, you just add, just like normal addition, you just add the magnitudes, respective magnitudes. So EBC cos 49 plus EBA cos 49. So EBC, so I'll write here the resultant electric field is EBC cos 49 plus EBA cos 49. We know EBA and EBC both magnitudes we calculated exactly same, that is 4 out of 21. So 4 out of 121, 4 out of 121 cos 49 plus 4 out of 121 cos 49. Again, take a calculator and plug these values and tell me the answer. 4 out of 121 multiplied by cos 49 then multiply it. You just add this 2 twice. So the answer will be 0.0433. This is the value of the electric field, and that much unit for electric field. What is the unit for electric field? Unit for electric field is Newton per Coulomb. Newton per Coulomb. 0.0433 Newton per Coulomb. So that will be the answer for this question. That's it. It's very simple, right? To practice. Thank you.